Hello and welcome to a video on quadratic equations part 2, brought to you by the Answer series. In this video we will continue looking at some quadratic equations. So I've got 3 examples here for you. I would like you to pause the video. I would like you to try those 3 and then see how you go, and then we'll do them together. In the first example, what I can do is I can group it. So I can take the first 2 terms and take out a common factor of x squared, and I can take the last 2 terms and take out a common factor of minus 16. I then have a common bracket, which I can take out of 3x plus 1, and I'm left with x squared minus 16. That bracket then factorizes into difference of 2 squares, and each of these 3 brackets will give me a solution. So there's a cubic equation that I can solve using the principles that we learnt within quadratic equations. So in this example, your natural reaction would be to multiply by your common denominator. Now your common denominator includes a term with x squared. If I'm going to multiply everything by a term that has an x squared, I'm going to end up getting a term in x to the 4, and we really don't want to be solving an equation in x to the 4. You will notice that there's an x squared plus 5x and there's another x squared plus 5x. So what I'm going to do is I'm going to let x squared plus 5x be equal to k. So my equation becomes k over 2 plus 12 over k equals minus 5. And now what I can do is multiply by my common denominator, which is 2k. So I multiply every term by 2k, and I get that. Write it in standard form, factorize the trinomial, and I get 2 values for k. But remember, I'm not solving for k, I'm solving for x. So in place of k, now goes back the x squared plus 5x. I get another trinomial, which I factorize, and I get my 2 answers. And with k being the other value, I get another trinomial, and I get those 2 answers. So there was a very clever technique I could use. I noticed that these 2 were the same. So I let that be equal to k, and I then managed to solve for x. The next example is a trig equation. So what we're going to do is use what we've learnt in quadratic equations and see what we can do with this one. First step I do is I take everything across to one side and make it equal to 0. I then group it. I group the first 2 terms and take out a common factor. I take out a minus sign from the last 2 terms. Notice I have a common bracket, which I take out, and I'm left with 2 sin x minus 1. 2 brackets multiply to give you 0, so one of them must be 0. So either sin x plus cos x is 0, which means I get that sin x is equal to minus cos x. And then remember, what we do is we divide both sides by cos x. Sin x over cos x is tan x, and minus cos x over cos x is minus 1. If tan x is minus 1, then x is 135 degrees plus n 180. And if you're not sure about the general solution, then you need to watch some of the trig videos to see what happens with that. My other alternative is that sin x is equal to a half. From the second bracket, sin is positive in the first and second quadrant, so x could either be 30 degrees plus n 360 or 150 degrees plus n 360. And don't forget, you need n an element of z. Example number 6, I have 2 examples here for you. The first one, they give you a root of an equation, and they ask you to determine the value of p and the value of the other root. The second one, they say to you, find a quadratic equation that has integral coefficients. Now, integral coefficients just means that the coefficients must be integers. In other words, no fractions or decimals, and they've given you what the roots are. So what I want you to do is I want you to pause the video. I want you to try these two examples, and then we will look at them together. A root of an equation is an x value that makes the equation true. So if minus 2 is a root, it means it is a value of x that will make this equation true. So what I do, in place of x, I put minus 2, and I solve for p. I now know that p is equal to 10, which means my equation becomes 3x squared plus x minus 10 equals 0. Factorize the trinomial and get the two values of x. They told you that minus 2 is a root, which means one of your answers must be minus 2. The question asked you for the value of the other root, so the other root is 5/3. You need to find in this example a quadratic equation with integral coefficients, and you've been given both the roots. Minus 3 comes from what bracket? It must come from a bracket x plus 3, because if x plus 3 equals 0, then x is equal to minus 3. But what about the 2/5? So if you think, if x is equal to 2/5, multiply both sides by 5, and you get 5x is equal to 2, which means 5x minus 2 is equal to 0. So that root of 2/5 comes from a bracket 5x minus 2. So the minus 3 comes from that bracket, and the 2/5 comes from this bracket. And all I now need to do is multiply the two brackets together, and you get your quadratic equation with integral coefficients. If you're not confident with doing it that way, I can do it slightly differently. The minus 3 obviously comes from a bracket with x plus 3, but the 2/5 must come from a bracket with x minus 2/5, because if x minus 2/5 equals 0, then x is equal to 2/5. Multiply these brackets together, and you get the following. So multiply each term together. You've now got an equation with fractions, so multiply by your common denominator, which is 5, and you get that. Collect together the two terms in x, and you get exactly the same quadratic equation. So it doesn't matter which way you do it, both of them will give you the same answer, where you're having a quadratic equation with integral coefficients.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.